Okay, continuing to look at some numerical graphs to describe what they look like, shape, center, and spread-wise. The next one we have scores on the final exam out of 100 and the number of students who achieved these scores. So this is like a graph that I might make for one of my classes. When I look at shape on this graph, I do again see a unimodal shape. There's just one high point, one mound. And if I sort of draw what the curve over this would look like, I do feel like I'm seeing a bit of a left tail here. So I'm going to call this unimodal and left skewed. As far as the center goes, what do I think the typical value on this test is? I would probably say for right now, anywhere between that 60-80 mark is the center or the pretty typical value there. So a 60 to 80 score. And spread. Now there's only 5 bars here, so it sort of looks like a small kind of squished in graph. But again, think of context. In that lower bin, we have students in this class who have scored between a 0 and 20%. In that upper bin, we have 80 to 100%, and we have everything in between there covered pretty well. So this has extremely large spread. Pretty much all grades possible are covered. Like this class really spanned everything. Not everyone, was lumped into this small area. Not everyone passed. Not everyone failed. Everyone's kind of all over the board. One thing that I see a big problem here with, to me, is the bin sizes. Because that was one of our questions was, do you think that there's anything wrong with the bin sizes and is there something that could be improved? So having the bin sizes of size 20 here, right? 0 through 20% all in one bin, 20 to 40 in one bin, 40 to 60, especially this upper area of having all scores of 60 to 80 in a single bin and 80 to 100 in a single bin, you're really lumping a lot of students together in those. I think that a better bin width on this might be 10. So that at least the different letter grades are parsed out. I want to see my 60s all together to see who earned Ds. And I want to see my 70s separate from that to see who earned Cs. And the same things with the Bs and the As, because those are very different contextually. And lumping all of the C's and D's together, to me, is not really all of that helpful. So in this case, I think that they've made their bin widths a little bit too wide, and a lot of information is getting lost in that case. Okay, so our last graph that we want to look at is we've got time in minutes across the x-axis and the frequency, and we are looking at the length of time dentists spent with their patients. So immediately when I look at the shape of this one, I see something different than what we've seen so far. I see a bimodal graph. I see two very distinct, mounds to this. Once you get out of the unimodal and once you enter bimodal or multimodal, you don't really need to talk about the skew so much anymore, unless it's extremely predominant on one side or the other. So I don't really see any skew on the outer sides of any of this. So I'm just going to leave it as bimodal. The idea of symmetric sort of loses its meaning here because symmetric, you need like one mound. So we don't really have that going on either. I'm just going to leave this as bimodal. When you have bi or multimodal and you're talking about the center, you're now going to have multiple centers. So I see a center on this left mound of maybe something like, I'm going to say about 12.5 minutes. And then we also have a center in this upper area of maybe like 22.5 minutes. So we have two centers now. Again, as far as spread, so let's see. We've got data all the way from the 10-minute mark up to the 30-minute mark, and we're talking about going to the dentist office. So to me, again, sometimes this is a little bit of a personal question. That's why you always have to have like a why whenever you're talking about spread. To me, the difference between spending 10 minutes and 30 minutes at the dentist office in a day does not really make all that much difference. That like is not going to change my day drastically. If you are going to the dentist, you've probably already carved out 30 minutes to an hour or more of your day to be dedicated to that. So whether you're there for 10 minutes or 30 minutes, it probably doesn't really affect your day all that differently. So in this case, I would call this small spread. 10 to 30 minutes is not all that large of a time span in a day, I'm going to say. So it's not that big of a difference during the day. Now, if I was going to the dentist office and I had no idea, knowing I might spend 10 minutes here or I might spend 3 hours here, now we're starting to get in, that would be more like a large spread where that's going to affect my day drastically differently depending on which one of those happens to me. So again, everything that we've looked at so far have been numerical variables, right? We've talked about time, those are numbers, scores, those are numbers, more scores, these magnitudes, everything we've talked about is numerical data. And there's more, but the two main graphs for numerical variables are dot plots and histograms. In a dot plot, you place a dot above a number line where every value occurs. So we haven't seen any of those yet, but we're going to. What we've seen so far, every example we've looked at so far is what's called a histogram. This is when your number line is divided into what's called bins, you've heard me say that now, of equal length. And then a vertical bar is drawn where the height is proportional to the number of observations inside that bin. If you change the width of your bins, you can change the shape of your histogram drastically, and you do have power over that. When you're making a histogram, you get to choose how wide or how narrow you want your bins to be. If you make them too large, you may lose too many details. So that was like in this grades one. I thought those were too large. I felt like I was losing some detail. I was losing some important information that would have been nice to know. So that can happen if you make kind of a too large choice. But if you make them too small, what can happen sometimes is that you can get so many bins that you actually are just overwhelming the person trying to look at the graph, and they may not be able to pick out the important information. So I don't think on any of these they were all too large. I think all these made nice shapes. I could see maybe on this SAT score, those look pretty small. The nice thing was how they actually laid out. Because they laid out in this beautiful symmetric way, it still made a nice graph. But what if they were kind of all over the place, like up and down and up and down and up and down? Having bins that small and maybe some more erratic type of data could cause it to be very difficult to look at. So in this case, I don't think it mattered. But it is also something that you have to be careful about when you're making your own. So when you go to start making your own, those are things you're going to want to think about.